have no disclosures. So I'm going to report to you today on neuroimaging of situational triggers for urgency incontinence. So I recruited women who had urgency urinary incontinence, who reported that they had triggers, environmental triggers that triggered either urgency or leakage. And that's a typical sort of latchkey incontinence situation. And people tended to report other situations related to running water, so washing dishes, taking a shower, and seeing public toilets. And I asked them to take photographs of those particular situations. And I also asked them to identify safe spaces where they didn't necessarily think that those particular situations triggered their bladder or made them worry about what they would do in that situation. So these tended to be relaxing situations, sitting at home on the sofa, watching TV, doing some sort of hobby, knitting, sewing, whatever. So I got them to take photos of that as well. And in all, we had 23 women who came in, an average age of 60 years, with 1.8 leaks per 24-hour period on a 3-day bladder diary. And they had a functional brain MRI scan while viewing their own images of these trigger and safe scenarios. And they saw them for 24 seconds each, and there were 8 scenarios in total, 4 of each, in a randomized order. And we showed them those on an empty and on a full bladder. And after each scenario, we asked them to rate whether seeing those images made them want to urinate less or more on a scale of -2 to 2, with 0 being no change. And we found that on an empty bladder, as we might expect, there was a slight decrease in need to urinate looking at the safe images and a slight increase looking at the trigger images. But on a full bladder, we found that they reported a significant increase in their need to urinate when seeing these trigger images. So when we looked at the MRI results, what we did was we compared what was happening, the activation in the brain when people were looking at the trigger images, to the activation in the brain when they were seeing the safe images. And I'm reporting here on a full bladder, so everybody had the same bladder volume. So these are the areas that had more activity when people were seeing these trigger images. And they include the middle frontal gyrus, which is the image on the left, the thalamus and caudate, which is the image on the right, and we also saw it in the precuneus, the paracentral lobule, and the inferior parietal lobule, which we also saw when we did the same analysis on an empty bladder, which I'm not reporting on here. So what does that actually mean? Well, the brain areas that were more active when exposed to the trigger images, and remember this is the same level of bladder filling, at the same time it's a randomized order, so there shouldn't be any change in bladder volume. These brain areas were associated with memory and multiple types of memory, so working memory, episodic memory, and memory retrieval, and visuospatial processing. And interestingly, conscious information processing, including previously experienced events and processing emotional stimuli. And we think this is related to the conditioned responses to these situations, such as the latchkey incontinence, the front door, the running water. Decision-making processing, awareness, and arousal regulation. And also we see some motor activation in the places that are responsible for urinary control. So in conclusion, this is a confirmation of conditioned urinary responses to environmental triggers that we can recreate. So we're showing photographs of these situations, and people are confirming that they do feel more desire to urinate. But we also see the brain involvement, that we see different brain areas that are activated when people see these trigger images than when they see safe images. So it's not just the looking at images. And we think this is important because this is another contributor to urgency urinary incontinence. And we can use this to use different therapeutic approaches, so perhaps a cognitive or behavioral therapy approach to reducing these conditioned responses. And in the age of these new non-invasive brain stimulation techniques, we can maybe employ some of these if we work out the brain mechanisms involved in these conditioned responses. Thank you.
Any questions?
Lovely work. How did you exclude other lower urinary tract dysfunction in these people?
So we excluded neurological, like MS and things like that, but we actually had a younger population than we usually do. We usually do geriatric studies, but we had a nurse screen them for other lower urinary tract dysfunctions.
Great study. Did you you looked at the visual cues, but often people talk about auditory cues, and they're in the MRI. They've got the headphones on. Have you ever thought about putting running water or that sort of thing?
Yeah, actually, we have. That's one of the sort of extensions that we need to do. But we started off with this. We didn't know how this was going to turn out, whether we'd have anything. And it's a little more difficult to standardise auditory cues. We were careful to standardise the pictures and how people took them and the resolution of the pictures. So that's a thing that we'll have to kind of work out a little bit for future work. But it's definitely interesting, yeah. And we've had people report that, for sure.
This is a biggie. What was the most frequent trigger image that the patient reported? Is it the door key or?
It's pretty universally the front door. I think there was maybe one person that didn't report front door, but the doing the dishes was also the kitchen tap running water was fairly common, and there was usually running a bath. Not many brushing the teeth, actually. I thought that might be a common one, but we didn't see that. Church could go either way. In some people, it was a trigger, and in some people, it was a safe space, which I found really interesting. Thanks.
Okay, thank you.